Hello everyone, in this video we'll be solving problem 1339, maximum product of a splitted binary tree. The problem statement is we are given a root of a binary tree and we need to return the maximum product of the sums of two subtrees. Looking at example number 1, we can get the maximum product after splitting the binary tree at the leg highlighted in red. The sum of all of the nodes on the left hand side is 11, while on the right hand side we have 1, 3 and 6, where the total is 10. Multiplying the two numbers give us the total of 110, which is our output. I hope this explains what the problem statement is asking us to do. Now let's switch to whiteboard and discuss how it can be solved. As we are looking for the maximum product by splitting the binary tree into two pieces, we need to use greedy algorithm to try all possible combinations, that is, try to split the binary tree at each leg and verify if the product is the maximum. Let's dive deeper with this example where we'll try to split the binary tree at the leg between 1 and 2. So on the right hand side, I'll have nodes 1, 3 and 6 totaling up to 10, and on the left hand side, I have 2, 4 and 5 whose sum is 11. Now that we have the sum of the two split binary tree, we need to multiply them to get the product and then compare it with the global variable to make sure it is the maximum. The next attempt should be to try to split at the leg between 1 and 3 to see if the product is better than the previous one. The same process will be repeated for the remaining legs in the entire binary tree. I hope this was helpful in understanding how we need to proceed further with solving this problem. Now let's understand how we can come up with an efficient solution as iterating through the entire binary tree multiple times to split at each leg is going to be inefficient. Let's say the total of all of the nodes in the given binary tree is x, which can easily be calculated using DFS or BFS. Now let's say I want to split the binary tree at the leg between node 2 and 4. As the total of all of the nodes in the given binary tree is x, if we remove node 4 from it, the remaining total will be x minus 4. In other words, the sum of all of the nodes after splitting the binary tree on the left hand side is 4 and on the right hand side is x minus 4, and multiplying the two together will give us the final product. To complete this run, the value of x is 21, so left hand side the value of the subtree is going to be 4 and on the right hand side it is 17. Multiplying the two together will give me the output 68. Let's repeat the same process, but this time we'll try to split the leaf node 5. After splitting, my left hand side will be 5 and on the right hand side it will be 21 minus 5, the total is 16 and the product is 80. As this is the highest so far, we'll preserve it. These two were easy calculations as both of the nodes were leaf nodes, that is, they did not have any child nodes. Let's use node 2 in our next run. So if we are splitting the tree with node 2 as a starting point, that is on the left hand side, we need to have the sum of all of its child nodes. If we do a DFS and run recursive loop, we can easily pass on the child node sum back to the parent node while avoiding duplicate calculations. So in this case, 2 will be added with 4 and 5 giving us the total of 11, and BT1 total will be x minus 11, that is 10. Multiplying the two together gives us the product of 110. In other words, we are building our solution based on the calculation that we did for the child node to avoid duplicity. With this solution, our time complexity is O of n, where n is the number of nodes in the given input. This is because we are iterating through the entire binary tree twice, first to calculate the total and second to calculate the separate binary tree totals for BT1 and BT2. While the space complexity is O of h, where h is the height of the binary tree. This is because we are running recursive loop using DFS to iterate through all nodes while maintaining the context of the sum of all of the child nodes at the same time. I hope this explanation was helpful. Let me show you how we can implement this using Python. For better readability, I've broken down the solution into separate helper methods. Starting with the getTotalSum method, which will iterate through the entire binary tree using DFS and return the total sum of all of the nodes. The other method is compute_subtreeSum, which does the same of iterating through the entire binary tree using DFS and calculate the sum of all of the nodes including the current one at each node level. That is, it calculates the left leg, right leg and add it to the current node value, which will give us the subtree sum. Then we subtract it from the total sum, which will give us the BT1 total. This is similar to what we did during the whiteboarding, where the total of BT2 binary tree is x minus 4, where x is the total sum. After calculating the product, we compare it against the max product and the higher value will be saved into that variable. This code, when submitted on LeetCode, beats 68% of the submissions in terms of runtime and 5% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.